So it gives me great pleasure to be able to introduce you this year's RBC Distinguished Lecturer, Dr. J. Famiglietti. When he just saw me with my introductory notes, he says, "Oh, don't worry so much, just tell them I'm a hydrologist." But that wouldn't do any justice to the long CV that I managed to download from him. So forgive me for reading out loud from his resume, because his CV is so long and impressive that I was unable to memorize it, and I would be afraid to leave out important facts. So Dr. Famiglietti is a professor of Earth System Science and professor of Civil and Environmental Engineering at the University of California in Irvine. And he's the senior water scientist at the NASA JPL, Jet Propulsion Laboratory at the California Institute of Technology. He was appointed to the Santa Ana Regional Water Quality Control Board by California Governor Jerry Brown. He started his academic career in 1982, doing his undergraduate studies in geology at Tufts University in Massachusetts. He then continued with a master's degree in hydrology from the University of Arizona and finished his education with another master's and PhD degree from Princeton University's Water Resources Program in Civil Engineering. Dr. Famiglietti's research group at the University of California investigates how the water cycle and fresh water resources are being impacted by climate change. They developed advanced computer models and use satellite remote sensing to track water availability around the globe. His work has been incorporated into several of the world's leading global climate models and provides the basis for future climate change assessments in the IPCC reports. Most recently, he and his students have pioneered methods using data from NASA's Gravity Recovery and Climate Experiment, also referred to as GRACE, to identify groundwater depletion in the world's major aquifers. And their work has highlighted unsustainable rates of groundwater use around the globe, from the Central Valley and the High Plains aquifers in the United States to the Middle East, India, China, and Australia. Dr. Famiglietti is also the founding director of the Center for Hydraulic Modeling at the University of California. And the center was formed to develop state-of-the-art predictive models to address high-priority water issues in California and the Western United States. In its brief history between 2009 and 2014, the center published a series of high-profile publications and reports, led important efforts in science communication and international water diplomacy, and built the capacity to advise state and federal government officials on key issues related to climate change, global water security, and sustainable water resources management. In 2014, Dr. Famiglietti moved the core of the center to NASA, where he now heads the Water Initiative and leads the Western States Water Mission. And both are strategic efforts to bring the resources of NASA to bear on regional to global water availability and sustainability issues, the topic of his talk this afternoon. Dr. Famiglietti is a regular advisor to the US Congress and the California Governor's Office on water availability, water security issues, and he has testified before Congress, and he has participated in numerous White House, State Department, Congressional, Pentagon, and California State Legislature briefings. He has directly briefed the international leaders, including former UN Secretary General Kofi Annan, former US Secretary of Energy Stephen Chu, and former US Secretary of Commerce Don Evans. He also actively communicates water and climate change issues in academics, business, government, and to the general public, and his work is often featured in international news media, including the New York Times, the Los Angeles Times, the Washington Post, the Guardian, the Economist, 60 Minutes, CNN, the Rachel Maddow Show, Al Jazeera, National Public Radio, BBC Radio, and others. I could never memorize this, you see. He appeared as a featured expert in the water documentary Lost Call at the Oasis, and he's a regular contributor to the National Geographic Water Currents. His scientific work has also been published in academic journals like Science and Nature Climate Change. As said, we're very happy and very proud to have Dr. Famiglietti here with us at the Water Institute's 4th Annual Research Symposium, and please join me in giving a warm welcome to Dr. Famiglietti and give him a big hand of applause.
I need to bury that long bio in a place where no one can find it. But thanks very much for having me. I really appreciate it and appreciate the opportunity to get out to Waterloo. I've been hearing about the program here for a long time, ever since I was a grad student, and had some grad student office mates that were Canadian, and would always talk about how great the Waterloo program is. So it's great to be here. So yeah, you kind of get a sense from my intro about the kind of things that I work on, and I think it fits in to the program today quite well, because I do really emphasize communication in my group now. And you had a session about science in the news, and I think that it is important when we have newsworthy work that we do, that we take the time to try to communicate and communicate effectively with the media. There can be challenges, and I'll show you one or two examples of those challenges as we move through the talk. These pictures are sort of highlights of some of the things that I'm going to talk about. So we in the intro, our work with the GRACE mission, the Gravity Recovery and Climate Experiment, was mentioned, and it's really revealed a lot of very, very interesting, if not compelling, dynamics of groundwater storage and groundwater depletion and water cycle change, things that are happening probably at a pace that's maybe a little bit faster than we thought, and that most of us know. So I'm very interested in sharing that with you. Of course, we've got California on the left, and the Middle East, and most of the strength of the signal that we see here, and I'll explain this in more detail later, but the groundwater depletion that we see is really Turkey, Syria, Iraq, and Iran, and then we were talking about some transboundary issues earlier, certainly fall into that category, and then of course India, Pakistan, and now that depletion signal, I'll show you in a more updated map, stretches across northern India up into Bangladesh. So I'll start off by talking about, start with the definition of water security. We hear it a lot, right? We hear the term water security, we talk about sustainability, and we should probably define it. I think that would be good. So we'll start there. And then we'll talk about what some of the satellite data are telling us. Mostly we'll talk about data that we've analyzed from the GRACE mission, but I'll show you some radar data as well that show the subsidence, the sinking of the ground that's happening in a lot of areas around California. And then what are the implications for water sustainability and water security? And I don't have any answers. I think we need to start having these discussions and talking with stakeholders and talking with our agencies and our governments, because we need to take action on some of these things pretty quickly. And yeah, then I'll finish up with some tales of, or really just encouragement, not too many tales, but just encouragement about the need for communication and really, communicating the challenge of water sustainability, or the challenge of communicating about water sustainability, because it's a difficult, it's a difficult thing to communicate, especially in heavily agricultural regions, where water rights suggest that you will have all the water that you want for your entire lives and your entire life and the life of all of your family members and whoever owns the property. But when the water's not there to sustain that, then things are starting to happen, and they're already starting to happen. So it's news that people don't want to hear, but we need to figure out how to communicate that. So let's start off with a definition of water security. The first one is one that I wrote for a proposal. Very simple. I just thought, what do I think? When I think about water security, what do I think about? And I just wrote this down. A region's water security is defined by its ability to provide a reliable supply of potable water to meet the various needs of its population now and into the future. And so by various needs, I mean things like growing food, producing energy, right? Water for the environment, water for humans, water for economic growth. The USGS expands this a little bit and starts talking about, actually what I find interesting about the USGS definition is down here. And it talks about protecting water reserves in the event of scarcity due to natural or man-made or technological hazards. And when I read that, I almost feel a little like there's a little terrorism, hint of terrorism, vibe in that definition. And the State Department brings in things like the extremes, dealing with flooding and drought, and water quality and environmental degradation, as well as the confrontation with the social challenges of poverty, of weak political systems, of social tensions, right? And so these are all things that we need to be thinking about when we think about water security and how it's going to impact us moving into the future. So what are satellites telling us about water availability? Well, so we use the primary satellite that we've been using in my group going back to 1995, 1996. We started doing some pre-launch work with a grad student of mine named Matt Rodell. And this thing was finally launched. This GRACE, or Gravity Recovery and Climate Experiment mission, was finally launched in 2002, and it's still flying today. And I like to say that it works like a scale in the sky. And I'll explain that in just a second. And you can see from this inset picture that the satellites themselves are not very big. Each one is about the size of a flattened minivan. They orbit at about 400 kilometers. They're separated by about 200 kilometers. And the reason I say that they work like a scale in the sky is that it's not an optical satellite. It's not taking pictures of the ground. It's not sensing any colors or radiation or thermal emissions. Really what it's doing is responding to the changing mass on the ground. And so as an example, think about these two satellites. Here they are. They're flying over the Appalachian Mountains. Okay? And there's just a huge snowstorm. And so there's more water mass on the ground. The region has gained water weight. And so when those satellites fly by, that region that has gained the water mass is exerting a greater gravitational tug on these satellites. And so they're pulled down just a little bit as they fly by. Okay? And it's kind of like standing on a scale. It's sort of what happens when you stand on a scale. Gravity pulls you towards the center of the Earth, and the scale gets crushed. So here the scale gets pulled down a little bit. And likewise, when they fly over a place that has been losing water, like the Central Valley of California, a huge agricultural region that's been experiencing drought since 2011 and a tremendous amount of groundwater depletion actually for decades. And so this is a place that's been losing water weight for a long time. So it exerts less of a gravitational tug on the satellites, and they float a little bit higher. Okay? And so by keeping track of the position of the satellites as they orbit around the Earth and then over time in a particular location, we can map out the regions of the world that are gaining or losing water mass because of flooding or drought or snowstorms or groundwater depletion on monthly and longer time scales. It works, it's pretty low resolution. So over large regions, for large river basins, large aquifers, 150,000 square kilometers and greater. Illinois is about 100,000 square kilometers. Southern California is about 150,000, 200,000 square kilometers. So it's not going to tell us how wet the soil is outside the building here on the Waterloo campus, but it is going to tell us what's happening in the, if you take a 200, 300 kilometer radius around Toronto, that's sort of the scale that we're talking about. So some other interesting notes about the GRACE mission that make it a challenge to use is that it doesn't tell us the absolute amount of water in a region. In fact, in many places, especially when it comes to groundwater, many places around the world, we don't actually know how much water is in the ground. Maybe you folks do around here, but we certainly don't in the Central Valley. So GRACE doesn't tell us the absolute amount, it just tells us the delta, the monthly changes. And it can't differentiate between, it really just tells us the total change, the sum of the change of all of the surface water and the soil moisture and the groundwater and the snow together. So it's up to us to use other data, and I'll show you a slide about how we do some of that. It's up to us to compile, that's how we do the research. So we compile the other data sets, and we validate, and we compare to whatever observations we have, and then we try to break down the signal into its component parts. And lots of the work that we've done has to do with groundwater. So that's GRACE, and it's still orbiting. It is giving us about 9 months of data. So the batteries are wearing out. So it's close to, it's not dead, but it's close to death. The batteries are dying, and we're getting about 9 months of data per year. But help is on the way. It's on the way in the form of the very cleverly named GRACE follow-on mission, or GRACE FO. And it is, the GRACE FO will launch in 2017. And it's basically the same mission. So, and the reason that satellite missions are super competitive. To get a satellite mission selected is very competitive because you've got a great mission on carbon dioxide, and you've got a great mission on sea level, and you've got one on methane, and they're all really important. So they're super competitive. And so we were lucky to get this one approved. And the reason we did is because we made the case that it was so important to doing things like tracking the ice sheets melting and the ice sheet contributions to sea level rise, and think the work that we've been doing with water was a big help. So hopefully we'll end up with a few decades of GRACE data. So that's what we're on track for. Here's what some of the data look like. And I show this because I want you to get a sense of sort of like how blobby the data are. And then I'll show you how we squeeze information from this. In this color scheme, and I will change after this slide, I will change the color scheme. In this slide, blue is drier than normal and red is wetter than normal. And each click is a month. So if you look at a place like the Amazon, if you just focus on a region, so it's dry season, and now here comes the wet season, and then the dry season comes in. So we start to see the sort of ups and downs of the seasonality, the changes in water storage that actually we'd never seen these before. So, in that sense, it's pretty profound, and we're actually quite privileged to be able to have access to these data. So if we drill down a little bit, let's look at California. Same sort of animation. Now I've flipped the color scale to one that hydrologists are much more comfortable with, which is that red is drier and blue is wetter. And that's because we didn't make the other animation, but we made these. And so now we're about to come into the California drought, which started in 2011, so we should see the state getting redder and redder, and then I'll show you some other ones later, and eventually I'll show you the rest of the world, and we'll all have a good cry together. We don't sit around and look at movies all day, although the people who were talking about using like SAS and stuff and how they could sit around and look at that stuff all day, I could look at this stuff all day. But for other people, it might be a little boring. So we also look at time series, and here's a time series for the Sacramento and the San Joaquin and the Tulare Lake basins in California, which include the Sierras over here, and the Central Valley shown in blue. So this is like all of the water in California, most of the water in California. And so what's cool about this chart is, again, it's the first time we've been able to track the ups and downs of the change in total water storage, well, globally, but now in California for these river basins. So it's like, you've never been on a scale before, and then you finally start checking your weight every day, and you see, oh, I'm going up, I'm getting fat, oh, I better, lose some weight, and then it's, going up and down. And so we're seeing the ups and downs, the wet season, dry season. In California, the wet season is the winter. But we also see the trends, right? So we can see those ups and downs. We can pull out some screenshots from the animations that I showed you, so you could see how the progressive, the dry season's getting drier and looking a little bit worse, and sort of a grace version of a drought map spreading out, and looking, well, we all know that red is bad, so it's looking really bad. But we can also do things now that we haven't been able to do before, and that is quantify what the water losses are. And so this is our drought. This is the drought in California that's been, and if you didn't know, I'll tell you, it's really bad. Okay? This is no joke. My wife leaves me all kinds of notes about not flushing the toilet and taking the bucket from the shower and watering the plants, and we haven't watered our grass since I don't know when. So the grass is dying. But if we want to throw some numbers on this, these last 5 years, California, or that region of the Sacramento, San Joaquin River basins, has been losing, it's like 20 cubic kilometers of water each year. That's 16 million acre feet, right? So whatever your favorite water unit is, it's not good. We can do the conversions, and it's not good using any units. And for reference, in California, there's about 39 million people that live in California. And our domestic and municipal needs are just 12 million acre feet. So we're losing more water each year than all 38.5 million Californians use each year for domestic and municipal supply. There's other features here. You can see that our wet seasons, these are the last couple of years. So we haven't updated. If we updated it right now, we had sort of a marginal, although we had great hopes for the big Godzilla El Nino, which you might have read about in the paper. It did not materialize. So when we get our new data, it'll probably be over here somewhere. But you can see these wet seasons, right? They're not really even, they're just about the level of all the previous dry seasons. So we're not getting any replenishment of the groundwater, and the reservoirs are emptying out, and we're all going to hell. But there's more information here too, and so I think you can start to see there's these other timescales of drought that are embedded that no one talks about because they haven't seen these data before. Although, we broadcast the heck out of them. But anyway, we write as many papers as we can and do all the communication that we talked about this morning. But look at this. I mean, arguably, we've been losing water since 2006. And this was kind of a small El Nino in 2010 and 2011. And really, we've been losing water this whole time. Right? And in fact, the numbers are something like 3 cubic kilometers per year. It took me a while to realize this, to figure this out. But what's really happening is that our winter, when we think about it, when we add all the water together and look not just at the surface water, but the surface water and the groundwater, right, all together, we realize that our winters, our wet seasons, come and go. We have good ones and we have bad ones, right? And when we have good ones, we get some bumps, as you see in the chart. When we have bad ones, we don't get those bumps. But the groundwater, as I'll show you in the next slide, just goes. Okay? And we've been depleting the groundwater for decades to fuel agriculture. And so when you add those together, you see that California's been losing water. And so we have a drought. The drought will end. But when the drought ends, even if the drought ended tomorrow, California still would not have enough water to do all the things that it wants to do, namely grow tons of food. And we grow a lot of food for, you guys probably eat some of our food. So I think this is, we'll talk about what that means for the future. I think that the California problem is, we face chronic water scarcity, and the problem is really a national problem because we're trying to grow food for, produce for most of the United States, but using only water, most of the water from California, a little bit from the Colorado River Basin, about 10%. So how do we get to the groundwater? We looked at this chart of the total water storage. How much of this is groundwater? Well, how do we get at that? Well, the GRACE mission tells us this, the change in land water storage, the change here. That's composed of the change in the snow and the surface water and the soil moisture and the groundwater, so the change in the big river basin like we're looking at here. And so in theory, we should be able to rearrange that equation and solve for the change in groundwater. And so we've been doing this for a long time and done lots of validation studies and everything through the years. And I'm just going to show you some of the highlights of some of that work today. But so we get our Delta S land from GRACE or from the GRACE follow-on mission, and then we need information here, right, from other sources. And what we use depends on where we're working. If we're working in China, we're not likely to get much information from the Chinese government. We know because we've made the trips and tried to work up the collaborations, and you can't do that. And I certainly can't do it now that I'm at NASA. So we cannot work with China. So we have to rely on computer model information or other satellite information. If we work in California, we have lots of data on the ground. And so we can use data on the reservoirs from the Department of Water Resources and data on snow from the Department of Water Resources, and the National Weather Service does a nice job putting out a regional snow product. We don't do a great job with soil moisture, although we're doing a better job now with the NASA SMAP soil moisture active passive mission. So ideally, what we're trying to do then is we get the total change from GRACE, and if we want to isolate the groundwater, then we have to physically remove that, strip off that mass of water above the water table, which is the snow and the soil moisture and the surface water. So we'd love to be able to do all this. Since I'm work at NASA now, I have to advertise for NASA. And I'm kidding, I really like this. I do like doing this. I like this, what I'm about to show you. So we'd like to be able to do it all from satellite, and so we'll get the Delta S total from the GRACE follow-on. I have a colleague, his name is Tom Painter, who flies around in a plane making very high resolution measurements of the snowpack, of snow water equivalent. And we're currently working on, we're hoping, in the US, we're going through this decadal survey of the National Academy of Science and Engineering to prioritize future satellite missions. I said it's really competitive. And so a lot of us in hydrology hope that we can take what Tom has been doing just in California on a plane and make that into a satellite mission. So we'll keep our fingers crossed. So hopefully we'll have some kind of remotely sensed or aircraft soil moisture. The SWAT mission is a mission that will launch in 2020 that will measure surface waters and inundation extent and river heights. And, so we'll get that information on the dynamics of surface water and storage changes. And SMAP, I mentioned, is the soil moisture active passive mission, which was launched at the beginning of February in 2015. It measures the moisture content in the upper few centimeters of the soil. Okay, so this is kind of what pops out of our groundwater studies in California. And what we're looking at is cumulative groundwater depletion in the Central Valley. And it's from a combination of the USGS data shown in red and our GRACE estimate shown in green, 1962 to about 2015. And the colors in the background represent represent the climate. Is it a wet period like the dark blue? Is it a dry period or drought like the tan? Or is it sort of moderately wet, moderately dry like the light tan and the light blue? And so the take-home message here is that groundwater's been doing this, right, for decades. And that's only half the story. The real picture actually goes back to about 1930, 1925. So the real cumulative depletion is about double that. But also, our behavioral pattern is that we get a little bit of recovery of the groundwater in a wet period, so that's when we see the little ups. And then we get a big drop in the drought, right, in the drought periods, and a little recovery and a big drop. So we're, headed towards the bottom of the Central Valley. It's not sort of like a tennis ball bouncing down the stairs. It goes up a little bit, but the overall trajectory is down. So, this doesn't bode well. And what we see in California, is really sort of a lens on the rest of the world, which is why I've spent so much time on this point. But if I didn't, then you have to give us back all of our strawberries and raspberries and everything. So what's happening out there right now? The average water table depth is about 2,500 to 3,000 feet. And so wells are going dry. We get thousands of new wells going dry, additional wells going dry every few months. It costs $250,000 to $300,000 to dig a well that deep. And right now there's a waiting period of 1 to 2 years. So if you are not as wealthy as your neighbor or smaller, it's the wealthier individuals or the bigger farms that will be able to have access to water. So there's these social inequities that are arising. Of course, the quality of the water is declining as well. There's the subsidence, which I'll tell you about in a second. So all these things, streams, groundwater depletion leads to stream flow depletion. These are all things that we see all over Southern California. And that's why everybody goes to Disneyland when they come to Southern California. They don't go look at the dry riverbeds. Okay, the subsidence. Subsidence, as most of you know, is much like letting the air out of a bicycle tire, right? If you let the air out of a tire, the tire deflates. In some aquifers, those that have a significant clay fraction in them, when you pump the water out, they flatten out. And so the ground on top of them subsides. So it's been going on for a long time in the Central Valley. This is a USGS scientist. His name is Joe Poland. This is a famous picture. I mean, if you Google groundwater subsidence, this is probably the first thing that comes up. So this is Dr. Poland in 1977 standing out here in the San Joaquin Valley next to a telephone pole where, the ground surface, the height of the ground surface is marked. And so in 1925, the ground was up there. In 1977, it's where he's standing on. And so that's about a 50-foot difference. And so that's about a foot per year. So I have a colleague, Tom Farr, at JPL, who uses radar to monitor the subsidence. And so he's looked over the last few years at a region. So here's the Central Valley. Here's the region of maximum subsidence is really where we're doing most of the pumping. It's drier there, so we use more groundwater, and so we get more subsidence there. And the region we're going to look at is right over here, sort of El Nido, and right over here, so right in this region here. So this is in the period sort of like what we call the last drought, 2007 to 2011. And those colors there represent, and the colors there represent a few, most of them are 2 to 4 inches, 4 to 6. The greens are 6 to 8 inches per year. But then in the lower right here, this is the growing season, May through October 2014. So this is the growing season in 2014. And now this is the much more serious part of the drought. And so now the subsidence rates have jumped up to a foot per year. Right? Yeah, 10 to 12, 12 to 14 inches per year, if not a little bit more. So that's a tremendous amount of subsidence, especially if you have infrastructure like we do, like aqueducts and pipes and gas lines and roads and bridges. And to make matters worse, then Tom updated this so the report came out, I think it was last summer, but he updated it through about a year ago. So he updated it through about February or so, 2015, and the rates were even greater. And so the maximum rates that we've seen, that Tom has seen, are 1.5 to 2 feet per year. Okay. So according to the USGS, that's the fastest that the record rates of subsidence that they've ever seen, and the water table's falling. Right, greater than ever. So here's Joe in 1977, and here he is in 2015. A little Photoshop. So that's kind of what we're dealing with. We talked about communication before this morning, and this is an image that I actually put it together from, I made it at my kitchen table. My cat was like literally walking on the keypad and stuff. And to the scientists, I'll say there's not a lot of information content in here. It's really just showing the cumulative disappearance of water in California using this sort of traffic signal coloration, right? But there's not a lot of spatial variability. But the resonance with the public is like off the charts. So like somebody said this morning, you don't have to tell everybody everything. Sometimes a simpler, this is a message that really resonates with people. This thing was all over the place in terms of, media stuff. So, we've learned some lessons. California, and I've said some of these already. So California, we have a drought, but really what we have going on there, and it's not, the preview here is that it's not just California, okay? We have a state of chronic water scarcity. We use more than is available to us on an annual renewable basis through precipitation and stream flow. And we make up the difference from groundwater, and we are just draining it away. It's a persistent state. It gets highlighted. We only worry about it during drought. And it's primarily due to our exceptional agricultural productivity. Right? We grow a ton of food. And so this is not a anti-agriculture thing at all. I mean, I love to eat, and I in fact had a hamburger last night. But we are going to have to make some decisions about how and where we grow our food all over the world, really. So it's important for the public to grasp that we don't have all the water that we, in California, don't have all the water to do all the things that we used to do or that we would like to do. So if anyone's seen the last call at the Oasis, there's a bit in there about the hydroillogical cycle. And it's really a reflection on sort of human behavior. So it rains, and everything's cool. We're apathetic. And then, drought starts to kick in, and whatever. We become aware, think about it a little bit, maybe take some action, maybe not. We get concerned. And then if it keeps going on, we panic. And this is where we were in California about a year and a half ago. It was total panic time. And then it rains. And that's kind of what happened with us. I mean, we just got average amounts of rain in California over the winter, and only in the northern half of the state. People are like, yeah, drought, what? And so it's really tough to communicate that things really haven't changed. We did not get significant refilling of our reservoirs or replenishing of our aquifers. We didn't get much out of the Godzilla El Nino. So the chronic means chronic. It's going to keep moving forward. So something that I've been messaging, and I've already said it to you folks, that given that California grows food for much of the United States, it might be time to recognize the California water problem as a national problem. In other words, start thinking about groundwater and water on a national basis, which we really don't do. And certainly don't do groundwater. Groundwater is state by state. And so, we need to start thinking about how to do that. My own personal opinion, water use in our cities may well be sustainable. Right? We have plenty of solutions, like we do sewage recycling in Orange County. It works great. Tastes wonderful. But agriculture at today's scale, and it'll be the other slides that I show you that may hammer home this point, that at the scale may not be sustainable unless we think about new efficiencies and make the changes that we need to make to sustain the water supply. So there may be solutions for metropolitan regions, but we'll be much more challenged in agriculture. So more conservation, efficiency, things like water pricing, innovation, on and on, the whole portfolio approach, which we always talk about. In California, the end members are either we're going to be moving water to California. I noticed a lot of people talking about silence has fallen over the room because everyone has their eyes on the Great Lakes. So either we're going to move water to California or we're going to move agriculture out over time. And of course, moving water to California will probably be prohibitively expensive. And agriculture is already moving out of California. So it's already moving to southern Idaho and to southern North Dakota. And I gave a talk in Florida, and people over there at the University of Florida said, yeah, I mean, there's plenty of farmers that are coming over buying up land. We do have new groundwater legislation in California. I don't know if you know that. It passed at the end, so we're finally managing groundwater. But it's going to take, from 2014, 27 years to implement. A couple years to form the groundwater districts, 5 years to write up the sustainability plans, and then 20 years to come into compliance with those sustainability plans. And given that we are doing so much depletion, it's not really clear what sustainability means. I mean, the classic definition is not using more than is, right? Only using the renewable part, but clearly we haven't been doing that. I showed you the groundwater chart, right? So we're going to have to be thinking about slowing rates of, like, managing rates of depletion. I think that's going to be the future. And so this is going to be a major global problem, as I'll show you in some of the slides. So, with respect to communication, most of what I just talked about, and even a little bit more, so, I take the risk of writing it up and publishing it. And so this was in the LA Times just a couple of weeks ago. So this whole thing about it being a national problem and us, chronic water scarcity. And that one worked out well. I've got other horror stories I can tell you later. What about the rest of the world? So, the first place we're going to look is not going to be, if you're a Californian, it's not going to be the Great Lakes region, so you don't have to worry. The place we're already piped into is the Colorado River Basin. And I've heard so many water managers say, well, we don't have to worry about it because we're just going to go get more water from the Colorado River Basin. And we do have these senior water rights, and I just think that all hell would break loose if there weren't enough water to go around. And California just said, well, the hell with you. We're going to take all of ours and screw the rest of the West. I don't think that's ever going to happen. But one of the things that hasn't really been discussed is the amount of groundwater depletion that actually happens in the Colorado River Basin. So it's not just California. I will show you that it's happening all over the world. And so we did a study. This was work that was done by Stephanie Castle, who was a master's student of mine. So here's our GRACE time series for the Colorado River Basin from about 2005 to 2014. And so you see the ups and downs, right? Wet season, dry season, but you see the trend. And what we wanted to know was, where's that trend coming from? And in particular, we wanted to know how much groundwater is being used, because there's like no information on it. And now that we've got this satellite method that we've tested many times in many different places, maybe we can go figure it out. But the other thing that I find a little frustrating is that there's so much attention on Lake Powell and Lake Mead, the two biggest reservoirs in the United States. And so much attention on the falling level of Lake Mead, which is important, and it's a good visual that reminds us that we're in a drought, and Lake Mead is, basically at its lowest levels ever, and getting close to the, where the intakes are, the lowest intakes, and so now we're lowering the intakes. We pay so much attention to the surface water. I was just kind of wondering about what's happening with the groundwater. And so, long story short, this is what's happening with this lower chart here is what's happening with the groundwater and the surface water. So we took this chart of the total water, and we broke it up into how much is snow and how much is surface water and how much is surface water in Lake Powell and Lake Mead and how much is groundwater. And this is what we get. Of the changes that we see on the top, the red, that's Lake Powell and Lake Mead. So they're actually managed and relatively flat. But it's the blue that's the groundwater, right? And so it is, you can see, it's unmanaged, it's very noisy, and it's decreasing. And it's disappearing at a rate of 6 or 7 to 1 compared to the surface water. So while we're putting all of our attention on the surface water, the groundwater is quietly disappearing. And that threatens the water security of the western United States. Okay, so no one wants to talk about that. So now let's look at the United States. And okay, we can talk about Canada too. So here's a trend map. We're looking at the water storage changes, the trends. You can think of them as almost cumulative water losses here in the US for the whole data record that we have. This goes through November of 2015. Starts in 2002. Blue is wetter, red is drier. And so we see the upper half of the US is getting wetter. The lower half is getting drier. Here's the Central Valley Aquifer, and this is the southern part of the High Plains. These are our two big food-producing regions, right? And they are running out of water. This is the Alaskan glaciers. This is an older, I'm sorry I cut this off over here. So got some Canada in another chart, a global chart, but I'm going to show you an older Canada right here, older North America. This is, I gave a talk at the Monk School not too long ago and showed this. So, you know, we've got this sort of wet spot here that goes from the upper Missouri up right across the Front Range. We've got the Alaskan glaciers here. I have to tell you that we're not super confident about, so we don't talk about, part of the reason I don't show Canada stuff is because there's a lot of post-glacial rebound as you get closer to the Greenland ice sheet, right? And so, and those rebound rates are not well constrained. So we actually don't talk about it I personally don't talk about it that much. The people who use GRACE data in Canada really do a really good job on, like, go out there, they get GPS data to try to quantify the post-glacial rebound, because there's mass changes that are associated with that have to be removed. What I'm saying is it's not clear that those big red spots are actually real, or maybe they're not these in particular. Okay? Maybe they're not as strong. And so I don't know, but I didn't want to show it to you because, you know, we're in Canada. Let's look at some animations of India and the Middle East. And so again, we're sort of looking at the cumulative disappearance of water. Most of it's groundwater. It's about 60% to 2/3 to 3/4 groundwater in these regions. And the Middle East one in particular, again, I think is really kind of compelling because we've got Syria, right? And we always ask the question about, well, is water really a trigger for a violent conflict? And I think a lot of people have weighed in on that in Syria and said yes. And I didn't realize this, but apparently water security and access to water is being used as a recruiting tool by the extremist groups. I didn't know that. Okay, global. So this is what the global trend map looks like. So it's like this map I just showed you of the US, but for the whole world. And the places that are, so again, red is losing water, blue is gaining. And the places that are losing the most water are the ice sheets. So Greenland and Antarctica, those are far and away, melting away, contributing to sea level rise. Then the glaciers are sort of the next level of highest level of depletion, so down in Patagonia and Alaska. But, you know, a lot of these other red spots, so Central Valley, High Plains, these are aquifers. The Huarni Aquifer, the North Sahara Aquifer System, the Arabian Peninsula, India, Bangladesh, North China Plain, the Pilbara region over here in Australia. Wow, you guys look depressed. So this is where we're at in the world, and just to show you how these map to the actual aquifer units. I had a student, Sasha Ritchie, who worked on this for her dissertation and looked at global groundwater stress. So we just took this map, and the next figure I'm going to show you is just taking those trends and mapping them to same map, but map them to a little coarser scale, the biggest aquifers in the world. And so here's the 37 biggest aquifers in the world. And the color scheme is the same. So all the ones that are red and orange are being depleted. So over half of the world's, so 20 of the, it's either 20 or 21. Let's go with 20. 20 of the world's biggest aquifers are past sustainability tipping points, right? They're being depleted, some of them at super rapid rates, like India, Pakistan, Middle East, Central Valley, the Huarni Aquifer. And these are all our big food producing regions. Okay, so we need to make some changes. There's a global change part of this too. This is a same, sort of just a different version of the same trend map I've made, the same global trend map that I just showed you. The IPCC models, you know, the climate change models, have been predicting that the wet areas of the world, the high latitudes and the tropics, will get wetter, and the dry parts of the world in between, mid-latitudes, will get drier. So for a long time, I've been asking this question, like, well, or just raising the point, I think we're seeing it, or are we seeing it? And just here's a chart from IPCC, the fourth report that shows what's predicted by the models by the end of the century. These are changes in precipitation. So blue, right, wetter, high latitudes and tropics. And we finally published a paper that took all those trends in the blue parts, the wet areas of the world, and they're getting wetter. And took all the trends in the red parts, the mid-latitudes, and they're getting drier. So what are the implications for water sustainability and security? Well, okay, again, so one of the reasons that I keep showing these commentaries is because it's the communication part. So it's really not enough for us to really write the papers. We have to go the extra distance. And so I do that through op-eds. This is a commentary in Nature Climate Change. You know, we have to go an extra step, or two or three, to get the message out. And the message I want to get out is right here. Groundwater depletion all over the world, poses a far greater threat to global water security than is currently acknowledged. And so I hope that I've kind of proven that to you. And some of the things, so here's where I get into sort of the fuzzy, I don't have any answers part, but I have a lot of concerns. And my concerns are that, you know, given what I just showed you, I don't think we're really ready. Canada's probably not ready. The United States is probably not ready. The world is not really ready for the water, the food, the energy future that the work that I've shown you today and others that are very similar to it, the implications that it suggests, and that population growth will only exacerbate, right? So it's not looking good. We have the haves and the have-nots of water. The WWDD, that's the wet areas getting wetter, dry areas getting drier. So the wet areas, those people are going to have water. The dry areas, right, they'll have less. And then if you live in a place where the water table is falling and you don't have enough money to dig that deeper well, then you're not going to have access to water. I don't think we're prepared for the social inequities, the potential for violent conflict, the climate refuge, on and on. I can tell I'm really depressing you guys. I hope that there is some beer out there. I really do. One of the things I put in here this morning, and it was in response to, you had a slide that said something about a think tank, and I think that universities are a great place to do the longer term, deeper thinking that needs to be done. Someone else was talking about longer term planning. Maybe it was you, maybe it was someone else. We don't have any long-term plan in California, and so I think our universities can play a leading role because our agencies are often not really charged or don't have the resources to conduct those long-range. They're not. Take the example of California. It's hard to plan for a crisis when you're in the middle of a crisis, right? So your backs are against the wall. So I think our universities can really help by playing that leading role. I won't really go into this. I just wanted to hear, these are actually some solutions on the groundwater side. Not solutions, but, so it's a commentary in which I pointed out the problems. This is from the Nature Climate Change paper. It's a commentary where I pointed out the problems, but then also said, hey, what can we do about it? And so there's a bunch of things, basically like social innovation. We need to recognize that we use way more water than we have available on a renewable basis. Sort of physical science, we actually need to explore the aquifers and figure out how much water is there, which we haven't ever done. Certainly need to be thinking about conjunctive water use. And then, some policy innovations. We really need to be thinking about groundwater as a critical element of national and international water sharing and water treaties, and that we don't really do that. Let me just show a few slides on communication and communication challenges. I'm not really sure of the order of these. I keep mixing them up. So I used to end my talk with this sentence. Once people truly understand the source of their water supply, or the sources, and how they are changing, then acceptance of the need for action and protection is far more likely. And what I meant by that was, as an educator, I feel like, well, if I tell people that, they get 50% of their water from groundwater and the other 50% from snow melt, and there's no snow, and the groundwater levels are falling, then they will understand that we need to manage and protect the groundwater. And that's not what happens. And I just want to see, okay, so I want to show you a clip of a meeting we had where I was encouraged to go show our first results. So we wrote this paper on California, some of the stuff that I've shown you today, groundwater depletion in California. And so this was, actually a US Congresswoman said, hey, so I had done some testimony for her committee, and then she came up to me afterwards and said, she was pretty old, so she said, look, young man, so I love her, you need to go take that up to the farmers and go up to Fresno and, go on their turf and just talk with them. And so this was, if we had had this discussion that we had this morning, I would have handled this. This wasn't, what do we call it, knowledge co-production? This was not knowledge co-production. This was me going in and like doing a microphone drop. It's like, yeah. And so you'll see that it didn't go well. So let's play that. Let me be abundantly clear about this. California faces a water crisis of potentially epic proportions. How we respond today will define who we are tomorrow.
Here locally, need additional storage. They built reservoirs for a reason. Shasta, Hoover.
If you owe the bank and the county taxes, you're going to try to farm as much as you can.
They're not going to make more water. The only solution to this thing is conservation.
I agree we should look into conservation, but that's not going to yield or have any effect on our groundwater shortage.
I didn't want to get into this, but your arguments about conservation and efficiency are just wrong. And if you're right that conservation and efficiency isn't going to get us anything, and if I'm right that there's not a lot of new supply out there, then what are we left with? Take land out of production. I don't know anyone who wants that.
Your arguments just don't make any sense. You have to live in the valley. You have to understand the management of water here.
Well, that's bad management, and you're one of the managers. I'm sorry. Every river.
They wanted to make clearly this statement that we do face a crisis now of epic proportions, and I said that. And I'm not sure that it really resonated, which to me is a little startling.
When we talk about water,
That's funny. We need a plan, and we don't have one, and it is complex. We're screwed. Some key thoughts. I've learned a lot since then. So just some things that I want to share, especially with the students that are here and even the young faculty. Our niche is to do the peer-reviewed, right? We don't need to just talk because we want to be heard. We need to talk and communicate about our research. So we have to keep work really hard to do that research that we do. That's what we do, right? But we also need to know our story and our target audiences. And in that case, I did not really know the target audience. So someone encouraged me to go. I thought, yeah, this is going to be cool. But there's something to be said for trial by fire and just going out and doing it. I really think that universities really do need to engage the public, right? But I have colleagues that think it's a nuisance. I think it's a responsibility, especially given the kind of work that we do. For the young people, there's not a lot of brownie points for doing this. It takes a lot of time. Those op-eds that I write, well, you put 2 or 3 of them together and you have another paper, right? And that may be more important for your tenure. So maybe this is the kind of thing you want to wait on. Or maybe we need to change our reward system a little bit in academics to recognize the people that are going out of their way to make these contributions. We talked about this a little bit during the break. You know, in hydrology, one of the reasons we haven't had a lot of traction on communication is because water is just so spread over, I mean, physically spread all over the place, but there's so many different subdisciplines. There's quantity, there's quality, there's, you know, surface water, there's groundwater, there's the unsaturated zone, there's contaminant transport, there's hydrometeorology, and, you know, it's very difficult for us to agree, like, say, the earthquake community. They can easily say, yeah, we need to better predict earthquakes. Done, right? And so we don't have those questions that we rally around. And I think that to really make a big difference, when we're talking about the big, higher level policy, we're really going to need to work with the food industry because it's the single biggest user of water. And so they can be stewards, and many, you know, I've spoken with the Farm Bureau reps in California, in the US, and in the time frame between when that clip was filmed, which was about 2009, and now, they've completely changed. So in that film clip, the farmers were like, yeah, screw you, give us our water. And now, you know, they recognize the situation in California, and they want to sustain the business, they want to grow food, and we want them to grow food. And so we need, this is just another stakeholder, it's another one of the sort of knowledge co-production things. But the reason I say that the food industry, we need the help of the food industry, is because they're so powerful, right? And so I always think that it will make a big difference if I'm in the United States and I'm going to Washington, D.C., if I'm walking in with some, I don't know, CEOs from Nestle or something like that, whatever, I don't even know the food. You tell me, give me some names, please. Anyway, I always think that it's going to be more impactful to be doing that rather than just walking in on my own. My experience has been it's difficult to get traction. You know, in the U.S., our congressional members are just swamped with all kinds of important things. So I could be in there talking about water, but the person who comes in behind me could be talking about terrorism or, you know, equal pay or gun control. You know, it's just kind of a shopping list. It kind of, you know, in the first panel this morning, I think her name was Penny, was saying, you know, there's lots of stuff you can do. And this is just some of the many things that we've done. And I just want to share again with the graduate students and the faculty that there are tons of things that can be done. Social media, lectures, blogs, outreach events, op-eds. When you have big papers, of course, press releases. NASA's great on the press release, by the way. They love the press release. You know, we need to be working with our water managers, and I used to do a lot of work in DC, and let's not forget the K through 12 stuff and teacher training, which I have found very, very rewarding, actually. I used to do some work with the American Museum of Natural History, and I thought that was a lot of fun, actually. Hey, to you youngsters out there, and I thought that the scholars did an awesome job. Practice your one sentence soundbite. Okay, the 3-minute thing was great. 3-minute drill was awesome, but you know, you're very rarely going to have 3 minutes. So practice your one sentence soundbite. We used to actually practice them in my group. So think about it. So one time, no, I won't tell you. Someone put me on the spot and said, well, what's yours? And I was like, I think this could be close to my last slide. So look, we need to work together. And as a community, I think that we need to work together to raise critical water issues to the level of everyday understanding. So that is it. Thank you. Hi.
Jay,
What's up?
my impression is your biggest problem in the States is a political one. You've got half of your politics don't believe in science and are basically
This is a problem.
controlled by big business like Koch brothers and so on. What you've got to do is convince the lobbyists, the food lobby, as you said. If you could get the Koch brothers to buy this, then the amount of pressure that would start happening in Washington
hear you.
would be
I'm
immense.
not on their speed dial yet.
So how do you convince a dyed-in-the-wool Republican that global warming and climate change and this science is a problem?
Remember when somebody earlier today said it's okay to say, I really have no idea? I really have no idea. So I will say, though, that with water, you don't have to really invoke climate change. I mean, we can and we should, but you don't have to. So, you know, you can point to the California or the Colorado, whatever Republicans and say, look at the mountains, man, there's no snow in there, right? Look at your reservoir. Here's the groundwater levels from the USGS. So you can do that. But back to your point about the governance stuff, that's a huge problem. It really is, and that's why I'm not maybe quite as optimistic about, you know, when you factor in the stuff that I showed you with the governance and the changes that are needed to deal with that, I mean, it is mind-boggling. But, and again, I think it's just a great role for universities for, like, you know, you've got this Water Institute and the stuff that you were shown this morning about the different pieces. You know, you've got the governance and you've got the science and you've got the engineering and you've got the, see, I remembered, right? And the economics, because you taught me about branding. Thank you for that. And it's stuck in my head. But, you know, you've got the pieces. And so, you know, that's not really, you know, where's that going to happen in Canada? Where's that going to happen in, you know, in the US? I think it has to happen at our universities.
We have one more question there. You go first. You go first.
Oh, hi, Dr. James. Thank you for your nice talk. I have two questions.
Yes. Is
So
he
the
allowed
first-
to, or can he have just one? I'll leave it up to you. Oh, you have just one.
Okay. Okay. Then, so you were showing a map of groundwater depression, especially in the subcontinent. So I was wondering, is there any measurement that shows that especially those groundwater depression is contributing to the glacier melting in the Himalayan region?
So when we did our study, we actually pulled out the glacier melt. So we corrected for the glacier melt. Yeah, maybe that's what you're asking. So I'm interpreting your question as, was there any glacial melting in there? I'll interpret your question in two ways. Can you, one interpretation is, can you use the GRACE data to get a handle on glacial melt in that region? And the answer is yes, and people have done it. Papers by John Ward and Alex Gardner and some others. So, and in the work that I've shown, is there any glacial melt in there? And the answer is no, we have pulled it out. Okay?
This is more of a question related to local, smaller scale, I guess, or perhaps it could be argued as larger scale in the Western world anyways. But how do you square the risk with groundwater, if you'd like to comment on this, with commercialization of water? You mentioned the N word, you mentioned...
Oh, I did.
You did?
Yeah, Nestle.
What, you know,
Yeah.
water bottling, this sort of thing. How do you
Well,
justify that? And I understand
I don't.
there's been issues in California relating to that.
Yeah. So what Nestle would say, so, you know, so interesting side note. So the Nestle story, so for those of you who don't know, you know, Nestle does a lot of bottling of water, and they have the rights to, I forgot the name of the spring, but it's in like the San Bernardino National Forest. And so the story was broken, you know, right in the middle of the worst part of the drought, that Nestle was bottling this water, and they actually their permit had expired. You know, I think the expired permit was less important than the sort of moral, ethical thing. Should they be doing this? Simultaneously, Starbucks pulled out of bottling water in California and just moved to a wetter region, like East Coast or something, or Great Lakes. And so I actually was on a radio interview with the CEO of Nestle Waters, Tim Brown. And this is on a Southern California public radio thing. And I actually teed him up in a very positive way. You know, Nestle actually has a strong environmental record overall. They do. Nestle Foods has a strong environmental record, as according to many independent assessments. And so I said that to him. I said, hey, you know, Nestle's got a pretty good record, and you know, what do you think? Are you guys planning on, because of the drought, are you guys planning on pulling out of bottling water in the San Bernardino Mountains? And he said, absolutely not. And if I could, I would bottle even more. So that was probably, you know, I'm surprised he didn't get fired. But, you know, his point was that the demand is there. That's his point. And we do, not we in this room, but, you know, people buy a lot of bottled water. The demand is there. Do I support it? No way.
Hi, Jay. I like the maps you have shown, and we learned that we are undergoing a crisis of lacking groundwater all over the world. But I have a question that, so the whole world is losing the groundwater. So where does the groundwater go? I mean, does it mean that we are losing the water to the ocean, or some places are becoming drier and other places are becoming wetter?
Both of those. So where does the water go? It doesn't get destroyed. And when you know, take the charts that I showed you and you add up all the water over the globe, and you know, it all adds up. And so, yeah, I mean, it basically gets redistributed in the water cycle, and much of what's being pumped ends up right at the high latitudes or the low latitudes, and there is a contribution to sea level rise from groundwater pumping. So it just moves to other places.
Okay, thanks. Feel free to say you have no idea what I'm talking about.
I don't.
I want to talk about options, and I want to frame the California water bond within this context, okay? So I teach a class called Water and Security, and in that class this year we had a case study where we compared Australia, South Africa, and California and governance responses across El Nino contexts, okay? And the three are completely different outcomes. And it seems, but of course, California, the jury is out, although, I don't know, you've some damning evidence, obviously, right?
Yeah.
But nevertheless, the crisis enabled the bond to be passed.
Yeah.
It's better than nothing, and the Groundwater Governance Act.
Yep.
It's better than nothing, or is it? So that's my question for you.
Yeah.
Can you give me your take
Well,
on the future of that?
I'm kind of in the camp of it is an important first step, and it had to be pretty flexible. It doesn't have a lot of teeth. There's like a tremendous amount of stuff that hasn't been defined, including whether we'll be monitoring at the individual well level, which I thought was like a fundamental part of the bill, but it wasn't. So my take is that it's an important first step, and if it were any stronger than that, or more specific than that, it wouldn't have passed. So, you know, that's all I got.
Good afternoon, Jay. First off, I'd like to say it was nice to see not one bottled water here in the building here today. Two,
I spotted one, and I won't tell you who that is.
Oh, you did? I'm sorry to hear
but
that.
She knows who she is.
I was curious what you felt about the possibilities of desalinization technology combined with solar.
Yeah, so desal, so the negatives of, so the positives of desal, of course, can generate a lot of water. But the negatives are pretty strong. It's very expensive. It's very energy intensive. And you have to do something with those brines. So I think that I hope that those are solvable problems. One thing to keep in mind is that I don't see that as being an agricultural solution. I think it's going to be good, helpful in metropolitan regions. We just use so much water for for agriculture. So when I tell people, when I think about science fiction, or if I, can't sleep and start thinking about 100 years from now, 200 years from now, what do you, or more, I see desal plants all over the place and pipelines, yes, from here to, to somewhere else, out of a couple of centuries or less.
Oh, hi, Jay. I just want to say we have good news and bad news. The bad news is that the Great
That there's no cookies out there, okay. All right, and the good news?
No, the Great Lakes water is actually, there's only less than, 5-6% is really sustainable.
Yeah.
So that's not a lot for everyone
I
around.
know.
So
I'm mostly kidding,
yeah, so just tell your friends in California we
I will.
don't have enough water.
I'll bring the message back. We get
The
nothing.
bad and the good,
Yeah.
well, maybe it's the bad news or good news, is that the only way we can get rid of people from California so that they move to the wetter regions is get Trump elected.
All right. I hadn't thought about that. All right, thank you. Thank you so much for that. No. The microphone has moved. Yeah, that, we don't need to comment on that. It was beautiful on its own.
Does somebody else want to? It's me?
Yeah, hi, Jay. Les Holdaway. I'm over here. Thanks for this. I wanted to take up on the point you had about, everyone's doing a great job learning and understanding the problem, but I really take what you're saying about having to spread the word. I spent a lot of years in documentary filmmaking. 2 months ago, I just spent some time with Michael Moore down in Flint.
Wow.
And we've been trying to get the word out here because I think the problem's the same here. We have water, but now we're changing it into something else.
Yeah.
So anyway, the point I wanted to say was, I think, from the learning side, I think you have to go all the way, maybe even over to theater, to get the word out. I think Bernie is a good example in the States that instead of going to an institution, I used to work for the Ministry of the Environment, people used to come to me with documents to print and send out to MPs because as directors they couldn't say anything themselves.
Right.
So I think you've got to find an alternate way of getting the word out.
Yep.
And I think part of it's theater, and I think Michael Moore is a good example of that.
Kyle, give me my card, and I expect to show up in, I'm just trying to think of a clever name, California 911, California H2O 911. I'm just saying, not bad, right? So that clip that I showed you was from a documentary called Last Call at the Oasis. And that was done by Participant Media, who did, they did Food Inc. and An Inconvenient Truth, and the people who worked on that one was Academy Award nominee and one was an Academy Award winner. And so it's hard to go higher than that. But what happened, the story of the theatrical run, there is no story. It was out for 3 days. And so, does the public, maybe now would be, if it was released in California, 3 months ago, it might have done great. But people didn't want to see it. It also hurt that it came out against the Avengers back when the Avengers was like the #1, first weekend movie. So I agree, and I do a little bit, I've done some TV stuff, but it's so transient. It's on and then it's gone. So I agree with you on the theater. I just don't, that was a pretty good movie. Watch it. You should tell me what you think. Maybe it sucked. I don't know.
Thank you, Jay, for a fascinating talk. I had one question related to, you were talking about well failures that's happening. Is there any work, or is it possible to correlate well failures to the GRACE data that you have to see, because again, in terms of communication, farming community would probably relate better to you spend $300,000 on a well, and it's going to fail in 10 years
Yeah.
now as opposed to a
Yeah.
longer time period?
That's a good question, and I would say in its current form, we probably so the GRACE data are super low resolution, but when we start to do the downscaling with, so one of on our research agenda at JPL is to combine the radar stuff that I showed you and also GPS. So you can improve the temporal resolution, you can improve the spatial resolution. So at that point in time, I would think that there would be a chance. Right now, probably not, but it's hopefully part of the future. And I hadn't actually thought of it, so I think that's really good. Thank you.
I understand California has also taken measures to bring down the domestic water consumption with bucket showers and don't flush the toilet and so on.
Yes, right. Don't come to my house.
The region of Waterloo has been in a similar situation about 15 years ago. And people are worried that they might be running out of water here and have to build a pipeline to Lake Erie and so on. And then the region decided to manage the demand and implemented water-saving measures, and they did it very successfully. And they brought the consumption per capita per day from the North American average of 500 liters per capita per day down to 250.
Yeah, that's amazing.
So it'll be interesting what the similar figure is for
So
California.
we've done a pretty decent job. So the governor basically required, although there were not very many fines, that we all cut our domestic water use by 20 or 25%. I can't even remember, 25%. And we did a pretty good job. I think we ended up doing like 24.5%. So no, I agree totally. I mean, we have to, first step is to reduce the demand. It's relatively easy, and of course it's cheap. It's not actually super inconvenient. I think we've been pretty spoiled with the amount of water that we've had access to. So no, we did okay. I think though, with the sort of weak El Nino, we're already seeing like the allocations of surface water are increasing. I'm not sure if the mandatory, so people are forgetting they're in the apathy part of the hydrological cycle. So, I mean, I love to have the rain, but the downside of it is the just loss of momentum on the longer term message.
Okay, we're taking one more question because we're rolling out of drinks, so we don't want that to happen. One last one.
Thanks, Jay. So you're at NASA, right?
Yeah.
Clearly.
Yeah.
And it's a fairly bleak outlook. I'm looking forward to some beer.
Yeah, that's why I work at NASA. I want to move to Mars. So,
I mean, NASA is clearly is tasked with the grand challenges, and this is clearly a grand challenge. At what point does NASA say, we do all the missions to Mars and Jupiter, we also do the Earth observation missions, but there are actually some bigger missions on the ground that we have to work with. Is that something that you think about, that you
Well,
that
I
you have
think
to
about
think
it, but I don't know how, so you mean actual work on the ground?
Yeah,
so
more
monitoring or the social side.
NASA identifies the problems,
it's so hard. It's so hard in NASA. So yeah, I think about it, and I think that I need another job. So we have started to talk about water security, global water security, right? And so this will probably be part of the discussions. It has been so I've only been there for a year and a half. I've just been so busy. And I can still do the I just put on my professor hat, and I can still do the communication stuff. And if I need to, I can talk to Congress. But that won't go on forever. And so we do have to. So we do talk about it, but it's very and the messaging. NASA is such a nervous organization. They are, and so they're very risk averse when it comes to the public communication stuff, understandably. Right? I don't know who saw, this was in the headlines a few weeks ago. The headline was, NASA smacks down climate denier on the Bill Nye's Facebook page. Did anybody see that? That was big headlines. And So what is NASA's climate change Facebook page? It's a person like you, right? It wasn't you, but it's a person who got pissed off at some climate denier and wrote on the Bill Nye's Facebook page, and it's signed like NASA climate change, hey, you're an idiot, you know. And so, you know, this person got in trouble, even though her comments were like lauded by the New York Times and the Washington Post. So they're nervous, and that's an extreme example, but they're nervous about, you know, can they have that role in talking about policy? At the same time, they want desperately to impact policy and to impact environmental management through the use of the data. So it's a tough place to do it, but we talk about it.
Okay. Thank you very much, Jay. Once again, thanks a lot. This is a
Thank you.
small token of appreciation.
Thank you very much.